start recording and start talking enough. Okay. Welcome back, guys. Online people, are you there? 2 people, okay, for joining me. People have decided that they won't come here again, so that's the online. So they can be just enjoying themselves. The last time I checked, someone was just sleeping on their bed. It wasn't even, we were doing calculation on the class. He was in his bed. The next time you know he has failed. I don't wish it on anyone, but I think it is some. I don't know how. I know how it feels to feel. I've failed at the back before in my life. The feeling is not good. Look at it. Hey, Charlie, it's not F and what's like. Okay, let's continue. We are recording this for YouTube, so we have to make sure I'm diplomatic about it. Let's talk about data acquisition. It's English language, data acquisition. I was having a joke with someone. I said, what does it mean to acquire? Okay. And the person said, you just get something, you get it. Are you okay? You just acquire. In fact, what I really wanted to say was that you buy. Are you okay? That's what I really meant by acquisition. Right. But at the same time, I'm just thinking, if it means just acquisition means buying, that means you just can't go and pick something, isn't it? Right. Sometimes you go to a place where you go to a shop and then they probably suspect that maybe that day you wore some short knickers and you are looking like, it's a suspect. So the security men start watching, right? Okay. And you feel a bit uncomfortable. You're like, what's going on here? Okay. And as you walk through the aisle, the security man also, and you realize this guy is really following me, isn't it? It's a very funny feeling. I don't know whether you feel that way or he's actually tracking you. Are you okay? So acquisition, if in your own bag, sometimes when you are picking it, your confidence is low. But now everybody's looking at you. It's like as if you went to a place, you're picking up your phone, it's like, they look, are you okay? And you begin to feel you don't even have the right to pick your own phone. Are you okay? To acquire is to get. Are you okay? To get. And at the end of the day, money is what's involved, right? Where we are in this lecture, we want to talk about how we get data, and it's money. Data acquisition means go out there and collect data. It's going to cost you, okay? Now, if you can't go out there and collect data, then pay up, give me some dollars here, okay? Because I've done that data work for you. So that becomes secondary data, okay? So the primary data acquisition methods in GIS make use of a few technologies. The first one is land surveying. So surveyors go about measuring what? Distances, they measure angles, they're able to compute coordinates, okay? Triplet of numbers, are you okay? And then they are able to now prepare plans, okay? Or they could go out there and just measure coordinates for any other points of interest. Are you on the same page? But when they are done, remember that what they have is what's going to feed into the GIS. Okay, so we talk about ownership of land. Are you okay? All that work is handled by land surveyors. So land surveying is one of the sources of data for a GIS. Are you okay? So surveyors use instruments such as total stations and the measuring. All that is free. So they sometimes they, if you're a surveyor, it's like you're a data collector. Are you me? Unless you move about that. If you yourself doesn't move about that, you cannot be like collecting data for everybody. Are you okay? You only collect data for someone to say, okay, now let's bring in the, what do you call it? The different layers of the road. Are you okay? Sub-base and all this. So but you are the one who really started it to tell them that this is the way they should do it, right? Okay. So basically, land surveying is a very important source of data. What you obtain literally are coordinates. Are you okay? But these coordinates join up, you get lines, you get polygons. This is a multi-line. I mean, you get polygons out of it. Are you okay? You can just get points out of it. That becomes what? Something that we can put into the GIS. All right? Great. Well, another method that we can use is called photogrammetry. So photogrammetry, as the name goes, using light to measure. It makes use of photographs. So you have like the drones that we see around. One of the main purposes for drones is you're able to fly over an area and take photographs of that area. And then once you're taking those photographs, you can create a 3D model of the place. Now, if I get a 3D model of this place, will you be interested in a survey on the ground again? Because a 3D model is saying that you have all the coordinates and everything down for you. Okay, so the photogrammetrist, the person who does this is called a photogrammetrist, flies a drone, a helicopter, or an airplane over an area, takes consecutive overlapping photographs, okay? And then from those photographs, you're able to generate a stereo model or a 3D model. 3D model is like getting XYZ for every point. Okay, right? Let me tell you what it means. It means if I had the 3D model of this building, literally it's like I have the AutoCAD for me by just flying over it. Okay, right? So when we do photogrammetry, that is basically what you do. The output of this will be the photographs themselves, okay, and the 3D model. Okay, right? Now the photographs are actually pictures. Excuse me. So they fall into the category of what we call the raster model or the raster data. We'll talk about this again. That's what I want to remind you that what you get from the land surveying is vector. Okay, vector is actually points, lines, polygons. Are you okay? When you use these to represent something, you call it vector. When you use raster, it means you are using a picture. Okay. Now, so you can get a picture from photogrammetry. Photogrammetrists can generate the pictures, give them to you as soft copy. Are you okay? And or you can also give you the 3D model, which contains the XYZ coordinates that you need for any project. Okay. All right. Now there's another method. Can you see it? Or they are even gone. Let me see. They're there. Guys, are you there? Okay, they are there.
Yes, please.
Okay, that's good. So follow what I'm saying, okay? Let me talk in vain. There's another method. You can use the GPS. What does GPS stand for? Global Positioning Systems. It's made up of satellites. About 24 satellites. Are you okay? Initially, the US started it. It's okay. The US Department of Defense, they did that. But now everyone, a lot of countries have their own. So the satellites move in orbits. And then the users on the ground, like you and I, who have bought smartphones with GPS location inside it. Inside we switch on location. Remember that you have a GPS receiver in your phone, okay? All right. So there you go. We are able to reset our location on the surface of the earth by simply talking to these satellites. So if I switch on my phone now, you can see it in action. Is that all right? All right. So this is what you do. You get your space segment, which is made up of satellites here. You get your ground stations, okay, the user segments. Those who are using the like airplanes that are flying from to New York, okay, they are users of the system. And now you have a control segment. So there are satellites and computers down at certain stations that are monitoring the satellites coming. So every time Uber, you make an Uber request, you and the Uber driver, you are all connected to these satellites. So imagine if you made a diagram like that. You see that you just sending coordinates. Are you okay? Getting your coordinates. Uber driver is also doing the same. It's communication. He's coming because he's received the final coordinates. Are you with me? All right. So space segment, user segment, those use it. Then you have so many satellites around the world. But where you are, you can only see about 24. Sometimes your location might not be very accurate. The location kind of, the precision gets diluted. Sometimes it's not very good. The position, you think that you're actually here, but it's telling you are here. Some distance away. All right. So that's how GPS works. We can obtain longitudes, latitudes from the based on the World Geodetic System, WGS 84. Are you okay? Which is actually a spheroid. Okay, I know you don't understand what this. Okay, but basically the world is round. So the approximate way to represent the world mathematically is through a spheroid, something looking like a sphere. But the Earth itself is not really spherical. It's kind of like it bulges at the equator. Is that okay? All right. So now we have all these satellites going around it. We are fixing our location based on a minimum of about 3 satellites. Mathematically, we can fix your position. Okay. All right. And then once you've done that, that position you are fixing is really this XY we are getting you. So GPS will give you coordinates. Land surveying will give you coordinates from distances and what? Angles. That is surveyor is standing there measuring he's moving. Are you okay? It's collecting XYZ, XYZ, XYZ. What are we using the XYZ for? It's helping us to design. It's helping us to plan. Are you okay? Engineers design, don't forget that. Engineers apply science, okay? And they design. Don't forget that. Once in a while, check the definition of it. So you know your role. Okay, let's take attendance at this point. It just came to me. If you're online, type your name and index number right now. If you're online, type your name and index number. Switch on your camera as well. When you do that, switch on your camera. Please take attendance here for me. Snap it on the page. Write your name, index number, snap it on the page. If you're online, switch on your camera. Let me see. I'm taking a picture. And then type your index number there on the chat for me.
So the system that I'm using, my camera cannot.
Please, I don't want discussion. Switch on your camera, because if you're not hearing me, that means you're not part of the class. Just switch on your camera. James, if anybody that's not hearing what I'm saying now, you are not part of the class. That's what it means.
So I can hear you, but I'm saying that my machine.
What am I saying? Your machine is what?
The camera is not functioning, so I can't show my face. That's
okay, James, that's fine, James. And the rest of you, okay. So in fact,
I'm also using Pentium. Sir,
okay, those are also
please,
using
I'm
Pentium.
also using Pentium 3 machine.
Using Pentium 3 machine. Okay, I'm taking the pic. So
yes, sir.
Don't come here next week and say I'm using Pentium 3 again. I won't take it. Is that okay? I'm forgiving you today. Go and get Pentium 4.
Please, that's the machine I have. Sir, please.
That's all you have.
That's the machine.
Me too. That's all I can do.
Yes, sir.
Okay. So
hello, sir.
Yes. Let's continue from where we are. You can switch off your camera. Ike, where are we? We are telling the story. Where are we? GPS has done what? Ike, say it in a more romantic way. You're meeting a lady and she's beautiful. You don't even know how to put it. And you are talking about mangoes and chicken and hen cook. Why is supposed to go straight for and say, wonderful. Anyway, okay, so guys, let's move on. We're talking about GPS. If you don't understand GPS, ask me a question. Please, I want questions on land surveying, photogrammetry, and GPS so that I can answer you. Take note that GPS satellites are about 11,000 nautical miles away from the Earth. 11,000 nautical miles. Okay, so nautical miles are a bit longer than the normal mile.
Yeah.
So please take note of that. I want more questions on GPS photogrammetry. Is that okay? With photogrammetry, you can have some errors and remove the errors. But for now, I just want you to just take that section. That's what we call the error due to tilt, error due to relief. Are you okay? When there are mountains, it doesn't work very well there. When you have high-rise buildings, okay, they all introduce errors. And when you have a tilt of the camera, are you okay? So normally photogrammetry, there's a camera under the plane that is flying, and then it's taking the pictures. Right? We want vertical pictures because don't forget that engineers, we deal with plans. Are you okay? We don't deal with photographs per se, because trust me, I can take a camera and take a picture of the buildings here. That won't be good enough for my design, would it? Would it be good if I took a picture of this place and I started designing a construction project on it? It would be wrong, isn't it? All right, so plan means planimetry, looking at something from what? The top, precisely the top, the vertical. Are you okay? It has to be vertical. So in photogrammetry, make use of what we call the vertical photographs. Okay? And then once that is done, you're able to get your 3D model and then the photos themselves. Are you okay? Which can be very useful for what we call photo interpretation. Is that okay? Yeah. Some bad boys did something in the forest somewhere and they made a mistake and they took a picture of the forest. Are you okay? They didn't even take a picture of whatever they've done. They killed some people. And then they posted it on Facebook. And when they did that, analysts took the pictures and then there was a lot of information that was extracted from the image that told, you heard of that story? Okay, the way you shake your head. Okay, so they took, say again. Yeah, what? Amazed, yeah, yes, it's a very, very powerful system. Okay. And then able to extract like the angle at which they shot the kind of rifle that was used. Can you imagine that? So information these days, you can't run, okay? You can just, let me tell you something. When people commit crime out there in the UK and elsewhere, they simply know that they were caught. Okay. They don't try to run this. They know that they're caught. There's too much information these days. Okay, we are the big data age. All right, so in collecting data, GPS in your phone already is collecting a lot of data. Okay, you can actually go into a certain mode on your phone that will always track your location. I hope you are aware. All right. Yeah. Okay. So basically, that's how we can have. Since you're not asking me a question, I'm adding a fourth one. You have a question on this, or should I ask you a question then? Maybe let me ask you a question. Is that okay? Data collection using this one. What is the benefits in case you have some kind of volcanic action? God forbid there is a volcanic action, and all of a sudden it's just flowing from that mountain on the other side. Are you okay? And you are the engineer for the city. Are you okay? You are the big boss. Are you get what I'm saying? You finished school, it's been 15 years. You got promoted. Are you okay? You are working on your big belly and your fast salary. Are you okay? But then now you are the first person to be interviewed. It's not so. But you are the engineer, you are called engineer, everything you are called. Are you okay? Now, how would you initially assess the situation? You need to measure, are you okay? Understand that this is the strength. If you don't do that, you are a failure, you are a disgrace. Because you cannot do any design without first understanding what you have in your hand. Do you understand what I'm saying? And that's why you need to first start with data acquisition. My question is that, which one of the three I've talked about would you immediately recommend? Do you hear this? Did you get it? Did you get this? This is how your questions are going to be set these days. I can follow what I'm saying. The questions should be set in a way that makes you think, all right? Which one of the three, Land Surveying, global positioning system, or photogrammetry, which makes use of airplanes? Which one of them would you use to measure the situation? And you always have to give an explanation. I keep saying photogrammetry, it has a low voice. It's okay, it's a shy type. Okay, so you said photogrammetry, what's your justification for this answer?
Because with the case of volcanic action, we really get
access to the exact location. But you need a full.
No, say it again.
You will
In
get
the case of
the volcanic eruption.
you won't get
You will be able to
access the place because you can even breathe the ashes and you die. It's poisonous, is that okay? And then you can have, I don't respond when you say grass. I hope you know that. I'm teaching. You already don't understand what I'm talking about. That's it. Okay, online, are you back? Okay, great. So I'm still recording. That's good. I get something to share. Please, do we get the solution now? So we don't want to be a hero. To be able to measure a distance and an angle, you need to be there. Are you okay? You need to be there. Are you okay? To be able to measure GPS coordinates, the user has to be at a place where the receiver is where the coordinate is being measured. So you need to now go and stand in the magma. Are you okay? Your shoes are melting, you are there. Seriously, getting your coordinates. Are you okay? Because you want to save the world, yeah? But this one, you save the world and we write right is stupid piece. Are you okay? Because this one we are stupid. Are you with me? You are not wise. What should you do? You fly a drone, a helicopter, or something. We don't see a lot of helicopters here. Can you realize? Have you realized that? So now you understand why you have a lot of helicopters flying in the movies. It means they actually fly a lot of helicopters there in reality. And so not all of them, they just sit in there, where are they going to? Are you with me? Some of them, they map and some are using for other things. Are you okay? Life should go on. Are you okay? You have to be active in life, not just like do something interesting to help your community. Are you with me? So supposed to be. Right, you're going to say something. Why are you going to say something? Please, why are you going to say something?
Yes. I don't know something very much because it's a nice image.
Yes. Thank you. That's a big plus. Are you okay? When you give an answer like this, you got an A+ in the exam easily because like I'm tempted to just. So when someone gives an answer like this, as I mark and the person's not doing well, I begin to just dang, what's going on? Are you okay? Very good answer. Do you hear what he said? The image itself has too much information for me. But as you look at it, are you okay? But I'm going to give you another dimension. So all of you listen to me. What if, and let me tell you a story, something happened some years back. There was a volcanic eruption and then it was spewing ash. Are you okay? Now because of the ash, all the planes moving in that direction were grounded. That is another dimension. So what do you do? Yes. Okay, so that will bring us to, please, this one I don't have that. Let me tell you what you're going to do. Possibly, the possibilities now lie with another system called remote sensing. Is that okay? Remote sensing. Is that okay? Remote sensing. So remote sensing allowed you to sense remotely. It's not like it's not a definition, it's not, but you can imagine that these also make use of satellites. And the satellites are, some of them are a bit closer than these GPS satellites. These are 11,000 kilometers. Some of the remote sensing satellites can be lower than that in terms of orbit. You know what the orbit is now, right? What's the orbit? It's a path around, okay, that an object is around another object. It's orbiting. If you're orbiting, it's a circular path. Are you usually okay? All right. So when you do remote sensing, the satellite is not necessarily orbiting. I always it's chasing them, but then some of them are really stationary. They don't move. All right. So now what you want to do is that you want to actually have a camera on top of this. And then the air is there, and then it actually takes an image of the ground. You can literally task the satellite to go to a particular place and take an image. That's a very expensive to task it. No, you don't pay. Are you okay? But for national security, we can pay. Are you ready? All right. Wait, but the remote sensing satellite takes an image the same way the photogrammetry, the airplane is also taking an image, but this is covering a larger area. Okay. Not only that, when we do remote sensing, what we call the camera up there is actually a sensor. The camera is a sensor. Are you aware? Do you know the camera is a sensor? What is a sensor? Yeah. What's a camera? Okay, so you are doing national lottery. When they mention the numbers, the numbers are 24, 28. Then you bite your fingers because you know that you didn't stick like this one. That's what you're doing. Please don't do that. It's okay. Okay. So please, can someone give us a concrete answer? What is a camera sensing? What is a sensor? What do sensors do? Have you heard of, do you know there's something called smoke detector? Yeah, it's a sensor. You know cars have sensors. What sort of sensors do cars have? Temperature sensors. Temperature is a thermostat. And proximity, whatever. Like you use infrared. Okay. Right. Do you get the idea of a sensor? So if a camera is a sensor, what is it sensing? So you've given some answers, but I want explanations. When you give the answer, what are we looking at? So I know you know that. You just display. Because I said it's shy. Yes, what is sensing?
The camera senses whatever you submit.
Oh, please. Whatever you point it to sense. Do you know smoke detector? What is it sense? Thank you. So when you say a camera is sensing whatever you are, what is it sensing? Objects. It senses an object. No. No, actually you said it, but you just don't know that is what it is. You said in your lottery application, he gave the answer, but because he's not sure. Can you take a picture when there's no light and you don't have any flash? Can you take a picture? It will be dark. Yes. So in the darkness, if you take a picture and you see a human being, what do you do? I've watched some short videos. They say run. Run. Because this one is violating some principles. My friend, do it. Hey, you run and it will come for the other side. Okay, is that scary? But basically, remote sensing is doing this. It can sense from the electromagnetic spectrum. I know you heard it before, but let me just remind you what it is. The electromagnetic spectrum is made up of the visible region. Are you okay? The visible region of the electromagnetic spectrum, are you okay? Is actually where we are getting red, green, and blue. How many of you know that when you mix all these colors, then you get white? So all colors are made up of these basic primary colors. Are you getting that? All right. So now, all the things we are seeing right now, all of us are seeing right now, okay, is coming from a mixture of these values. R, G, and E. Are you okay? When you switch on your camera, that's what it's sensing. What's the source of that light? The light we are seeing right now. If we are to take a picture right now as a class, what is the source of that energy? What's the source of the light? You know it. You know it. What is it? The sun. The sun. Is that okay? The sun. Please, don't be ignorant. Is that okay? It's a funny story of a guy who was approached by some two little kids, and the kids were arguing about the moon. And they were like, the moon is not really what you think it is. And this guy, no, it's like that. It's closer to us. It's not closer to us. Are you okay? It's an argument between two children. Are you okay? So they approach the big brother. Are you okay? You know, big chairs, like, you know what I'm saying? Like, haircut on point, everything. All right. And then we go like, oh, big bro, we are arguing over this, but you settle it for us. You are a big man. Do you know what the man said? I don't live in this area. Some of you didn't get a joke. It will come in exams. This joke will come in exams. Is that okay? In 10 minutes online, you have to rejoin. Is that okay? But if you have a question, please ask me. 2:45. So we're about to close, okay? We need to just do 2 hours instead of 3. Is that okay? I've got a lot going on. It's all right. So I'm going like this. I know the way I teach. So 3 o'clock bank, I are done, okay? I knew you wanted to stay longer. But please, we are finishing at 3. Is that okay? Are you disappointed? What? Look at his face. It's lying. It's very exciting. Hey, what's that? You joking? So what do you do? Should we shut our videos?
When they transfer the wall, if I can
What's that? It will be have the video. 2:44 p.m. Ike, please, if you don't understand what we're talking about, just say it. I'll go over it. If you don't understand, tell me. Okay, so remote sensing, let me talk more about remote sensing. Or you can ask me questions about it. It's simply the satellites are launched on the, you put it on the rockets, okay? Then you fire it, then it goes, okay? When it goes, there's a procedure, then there are modules, okay? Then it splits, then it spreads, then there's a solar dish on it, then it starts charging its battery, then it orients itself. All this while it's sending messages to the ground. There are codes, computer codes in there that's telling it the orientation, perfect orientation, and the first images come to the end, okay? Right. So that station is just one. It's not like control stations for this one, that global positioning system. Okay. Right. Here, the position of the satellites determine your position on the ground. Global positioning system. Remote sensing, one satellite mission out there. I want to take a picture of Ghana. So I send my satellite, put it in my rocket, I send it up there. It starts taking pictures of Ghana. Are you me? I'm done. So anybody can send a satellite up there. You even heard of this private university that sent a satellite to space. You heard of it. All nations did it. What happened to that satellite? Is it still there?
the last time I checked, it was still there.
It's still hanging there. Okay, they are now. Okay, so please, what I'm talking about, you are capable of launching. Okay, so visible region of the electromagnetic spectrum. What is electromagnetic spectrum? X-ray, gamma ray, short wave, TV wave, FM. Okay. Visible region, red, green, blue, infrared, ultraviolet. All those things are part of what we call electromagnetic spectrum, in which the shortest wavelength are the most dangerous. Okay, so most of the radioactive substances are emitting gamma rays. If you sit by it like 2 minutes, you should know that your life has become short. Yeah, because the gamma, which is the lambda, which is the wavelength, is very, very, very short. Are you okay? And when it's short, the energy is high according to Einstein's law. Are you okay? All right. Now that's not what I'm talking about. I'm only describing how we call the electromagnetic spectrum. The remote sensing satellites don't necessarily take a picture of the Earth. They can also measure from the infrared region of the electromagnetic spectrum, which is interesting. Are you okay? Now let me tell you something. Sometimes people work in dark rooms. Okay, because when you expose certain materials to light, they react. How are they able to work in the dark room? They use infrared. So even in darkness, infrared can allow you to see to a certain extent. You can have an image using infrared. Okay, you watched a documentary in which they were tracking the tiger in the night, and it was night, but they could see the tiger, isn't it? Have you thought about it? Okay, and it's even said that butterflies do have that characteristic. Sometimes, have you seen the butterfly flying so close and you ask yourself, does it not know I'm here? Okay. But then it flies so randomly that you can't catch it. See, God has done it that way. Literally, it's actually sensing. It's not really seeing. If it were seeing you, it won't come. Is that not so? All right, guys. So in remote sensing, we actually measure from the sun is the source of energy. Okay. All right. Now the energy emitted from the sun reflects, interacts with the atmosphere. Okay. And then reflects off the objects. Okay. So you are saying that it's sensing the object. It's not sensing the object. It's sensing the reflected energy of the object. Now do you understand that now? And then that is now retransmitted back to the sensor. Now the sensor now, depending on its characteristic, whether it can measure infrared or it can't, it just records what has come to it. So it takes it and say, okay, I see algae. I can sense algae. Are you with me? Right. Then you keep on going on and on and on. And you can now have different types of images depending on the type of sensor. We have what we call multispectral IoT sensors. And we have spectral sensors. So the spectra is referring to the wavelength. So I can take a certain image of all of you now. That will tell me which one of you is not feeling well, which one of you is feeling feverish. That's because I'm not really taking a picture of you. I'm actually measuring from you. Are you okay? So ready? You will not like the image you see, but I will know what I'm saying. I'm saying that this guy is not feeling well. Are you okay? All right. It's the same with that temperature gun that they use at the supermarkets when you're entering. Do you see anything coming? Do you know that if the place is dark, you can still check your temperature? Right. Okay. Wait. So that is how it works with that. So we can measure from this, okay? But near infrared, far infrared, etc. Different wavelengths. Application areas are very many. Too many. They are varied. You can actually use it to measure. Sometimes US knows that there is some kind of, covert activity in the Middle East. How do they get to know? They're able to use this remote sensing to now get to know that a certain place, the temperature is weird. You can do an analysis and know. Now something is going on but underground. So it renders the temperature on the ground to be different. So let's assume that there's water moving underground, huge water here. It does affect the ambient temperature, whatever the temperature at the moment. Where do you agree? Okay, so remote sensing has a lot of activity. At the end of remote sensing, what do you think we get? In our hand, we get an image. Okay, we get an image. Now, let's see one word. Remote sensing, the image that you get has what we call the resolution. Okay, remote sensing, you get what? The resolution of the image. What is the resolution of the image? It depends on the square, the number of squares in the image. It's all right. We will talk about this again. It's okay. The resolution determines how sharp the image is. The resolution determines, but the resolution is one of the reasons why people buy what? iPhone. It's a resolution. It's okay. And also, if the resolution increases, realize that your memory is affected because now you have too many squares representing the image. And so your images are very heavy. Do you know very good pictures are always very heavy? Yes. That is coming from this, the word resolution. There are two types of resolution. We have spatial resolution, then we have spectral resolution. Spatial resolution has got to do with how sharp and distinguishing the objects are, how we can distinguish between the objects. While spectral resolution refers to the spectra, the wavelengths that we are collecting. If you are collecting from this channel, the red channel,